Good morning, students. My name is Neena. I'm your new chemistry teacher. I hope all of you are safe and let's learn together from today. Okay, I hope Ragi ma'am completed two previous chapters. So I am planning to start about the third chapter. What is that? Periodic classification of element and periodicity properties. Okay, let's start this chapter. Okay. We are living in a magical world, isn't it? The world made up of chemistry. We can find chemistry everywhere. In our body, also, chemistry is there. Everywhere we can find chemistry. If you are sitting in your room, you can find chemistry in room. Everywhere we can find chemistry. So, chemistry makes the world magical. So, it is necessary to learn about chemistry and it is necessary to learn about more properties, more compounds, elements, substances, and all those things. So, in this chapter, we are learning about the periodic classification of elements. What do you mean by an element? Elements are the combination of molecules. Elements are the basic substance of all compounds or matter. So, why it is so special? What is the necessary of the classification of elements? Do you have any idea? So I already said elements are so important because our body is made up of elements. This desk is made up of elements. This our phone is made up of elements. Everything is made up of elements, isn't it? So elements are very essential to us. So it is very important to learn about elements, the nature of elements, the physical properties, chemical properties, and all those things are very essential to us. So learning about the elements is essential. So the classification of elements also essential because classification made easy of the learning about elements. If we go to a library, for example, if we go to a library, we know only the name of the book. I know the book Art Jeevitham. I don't know which is come under which genre or which genre or who is the author, anything. Nothing I don't know. So I know only the name Art Jeevitham. But if we go to the library, we can identify that. We can identify the book in the novel section. So we identified that it is a novel and we can see the name of the author and all those a particular arrangement is there in the library. There are stories and all those things. So reading is a good habit. You have to improve that reading that habit. Okay. Similarly, if we go to a library, we can see the classification of books. Similarly, there is a table called periodic table. I hope all of you are familiar with that. In that table, there is a classification, there is a systematic classification of elements. This table is known as periodic table. So in this chapter, we are dealing about or more about periodic table and today's class we are dealing with the history of periodic table. Okay, let's start. Okay, let's start the history of periodic table. If we check our school or Gokulam school, it has a history. It has an old story. For everyone, there is a history behind us, isn't it? Similarly, this periodic table. We know this periodic table, isn't it? This periodic table also has a history, like our school, for like everything. And there is a correction. I found out that there is a correction in your textbook. In your textbook, they are given that there are 114 elements in the nature, but it is wrong. There are 118 non-elements. So there are 118 elements. So you have to correct that. They are given 114 elements, but it is wrong. There are 118 non-elements. In that, 90 are natural. Rest of them are man-made or artificial elements. So let's check this periodic table. Here you can see the columns, all those things. There are 118 elements. You can see 118 elements. Isn't it? How this periodic table got this beautiful systematic structure? That we are going to discuss. The first earlier attempt of periodic table is done by Aristotle. He classified elements as metals and non-metals, but he couldn't explain anything about metalloids. And then the next important model of periodic table, brief model of periodic table came. It is by the famous scientist Dobreiner. He is the scientist Dobreiner. He classified elements as triads. By hearing the name triads, what do you understand by that? Triads. Triads. Tri means 3. So here you can see the picture of the triads. In that he classified elements in our group. You can see 3 elements, isn't it? Lithium, sodium, potassium. Similarly, calcium, strontium, barium, chlorine, bromine, iodine, isn't it? So can you identify any similarity or can you find any relation between this atomic weight of lithium, sodium, potassium? Can you relate or can you identify any similarities? There are some similarities. That is, he classified elements in the by the property of atomic weight. That is, in each group of 3 members called triads. In each group there are 3 elements, so it is known as triads. The middle element had an atomic weight about halfway between the atomic weight of the other 2. For example, if we take lithium, sodium, potassium, the atomic weight of lithium is 7, sodium is 23, potassium is 39, isn't it? If we add the atomic weight of the first element and third element and we find out the mean of that, we will get the atomic weight of second element. If we check here, the atomic weight 7 plus 39 will get 46. What is the mean? Half, isn't it? So how many elements are there? We have to find out the mean of that. So there are 2 elements. So the mean of these 2 elements atomic weight is 23. So that is the atomic weight of sodium. By this method he arranged the elements. Okay. But he couldn't explain more about other elements. He can only classify some elements or few elements. So this method is discarded. So his work is discarded. So we know that we studied in a structure of atom. One first model will come and there will be some demerits and then second model will come, isn't it? What was the first model? Dalton's model, Rutherford's model, Bohr's model, like that is there. Similarly here also a history. So we'll check the next model. The next model given by Charles-Courtiers. He is given the next model. Here you can see a cylindrical model. Look, here you can see the cylinder, isn't it? It is a cylindrical model. So it is known as cylindrical periodic table given by Charles-Courtiers. He arranged the elements in the increasing order of atomic weight. But this also didn't get more attention and he couldn't explain about further elements. Only till titanium he explained the properties and he can classify the elements in the cylindrical manner. But further he failed to explain the other properties. So the next model came. The next model, we all are familiar with this. I hope you studied this all in your 10th standard. So let's refresh all those things. So the next model given by, do you know who is this? Who is this scientist? He's a very well-known scientist named Newlands. His way of arranging elements was quite interesting. He did in the year 1864. He's a British chemist and he arranged 62 elements. He arranged 62 known elements. In that time only 62 elements were identified. He could classify the 62 elements. He also arranged the elements in the increasing order of atomic weight. And there is an interesting fact. I hope all of you know Saptaswara in music. Sa ri ga ma pa da ni sa. So the sa, the first sa and the eighth note, that is again sa, isn't it? So he also identified a music in elements. Isn't it interesting? Like he arranged, here you can see the element, his periodic model of periodic table. Here you can see 1, 2, 3, 4, 5, 6, 7 and next element F. F has some resemblance with hydrogen. If we arrange the elements in the increasing order of atomic weight, every 8th element repeating the properties of the first element, like physical properties, chemical properties, all are repeating. If we check again, we know in this modern periodic table, chlorine is in the fluorine and chlorine the same group, halogens group, isn't it? So here he arranged the elements in the increasing order of atomic weight and he identified that every 8th element is repeating the properties of the first element. So it is known as the Newlands octaves. Oct means 8. So this law is known as the law of octaves. Here you can see that, isn't it? But there is also some demerits. If you check here, you can identify that cobalt and nickel are placed in the same column or same block, isn't it? So it is not good. How can two elements have the same properties? We know that all elements are different. All elements are different, but they have some similar properties, but all elements are different. They have their own values, they have their own place. They have their own unique place in the nature. If we take us, we all are unique. We have our own properties, we have our own strength, we have our own nature, isn't it? Similarly, elements also have the same property, but he arranged some elements in the same block. So it is not correct. So this model also discarded. Here you can see in about the Newlands law of octaves. The law of octaves says that every 8th element has similar properties when the elements are arranged in the increasing order of their atomic masses. But there is a demerit. If a demerit will come, what happened? Will withdraw that model. So the again new model came. Here. Newlands arrangements of elements octaves. Here he is given. Several elements were fit into the same slots. We have seen that here, cerium and lanthanum. Look, here also some elements are put in same group. So it is not specific. Cobalt and nickel, here cobalt and nickel, all those things. Then elements with dissimilar properties were grouped together. For example, halogens were grouped with some metals. Halogens. What are halogens? What are halogens? I hope all of you know halogens. Fluorine, chlorine, bromine, iodine. Iodine are known as halogens, isn't it? Some halogens are placed with non-metals or with metals. We know that halogens are non-metals. but they placed with cobalt and nickel. Cobalt, and here you check cobalt and, so here we can see that cobalt and nickel placed together. So there is no a proper place given for a metal. Two metals were put together, cobalt and nickel, barium and vanadium. You can find out more from this table. Okay, and another demerit is these elements are showing the repeating properties or similar properties by arranging the increasing atomic mass. After calcium, the other elements are not following these properties. This is another demerit. And another demerit is later so many elements were identified. That time there were only 63 elements. Later so many elements were identified. So those elements are not showing any properties, and he couldn't explain about what later discovered elements. He couldn't explain anything about that, what will be their properties, anything. So these are the demerits of Newland's octaves.